Hello, Pre-Call World. In this video, I'm going to be doing section 1.4. It's talking about extrema and average rate of change. Obviously, you can still read. Pretty much, this is going to be talking about analyzing graphs a little bit more. So, in this graph on the left, we have this is a to the fourth function. X to the fourth is your highest value. But pretty much all you need to notice is that we have something called a relative minimum and an absolute minimum. Same thing, relative maximum, absolute maximum, they're going to be along the same lines. Pretty much all this means is, see how this point is lower than that point? So kind of like absolute zero is lower than 0 degrees Fahrenheit. Absolute minimum is just your lowest point on the graph, or absolute maximum would be your highest point on the graph, vice versa. This would be your relative minimum because it is relatively, it is lower than the points around it. Just like we would have a relative maximum because it is higher than the points around that. We also have something called a point of inflection, where basically your graph just kind of changes concavity. So it changes from being a downward looking turn to being an upward looking turn, or vice versa. It could also go from going up to down, where the point right in the middle, where it starts to change direction, is called your point of inflection. Alright, so let's start with a little bit of a simple example. So in this one we are determining the intervals on which the function is increasing, decreasing, and constant. So in graphing this function, so all we're doing is, for increasing it's just going to go up, decreasing it's going to be going down, and constant it'll be staying one number for a long time. So in graphing this, it looks like from negative infinity it's still decreasing all the way down, and then once I get to about here, my relative minimum, it starts going up to my relative maximum, and then it goes down forever and ever. So the points that I need to know, it looks like my relative maximum is at 0. So from this point here, I need to determine what that is so I can calculate my minimum. So it says left bound, I need to get to the left of my minimum. So there it is to the left. I'll hit enter. Again, this little arrow will come up there. I will go to the right. It now says right bound, so I'm to the right of my minimum. Hit enter, guessing, I don't care again. So I hit enter again. So it looks like 2 2/3, negative 2 2/3 is where my minimum is. So this function is decreasing from negative infinity all the way to negative 2.66666, or negative 2 2/3. So from, a little different color, decreasing from negative infinity to negative 2 2/3, and from, looks like 0 to infinity is also decreasing, so from 0 to infinity, and then between 0 and negative 2 2/3 my function is increasing. Okay, negative 2 2/3 you can also write as, let's see, negative 8/3, which is actually probably preferred. So you may want to write that as negative 8/3 instead of negative 2 2/3. Okay, that's all there is to that one. All right, looking at our next example, we're going to have the same directions again. Determine the intervals on which the function is increasing, decreasing, and constant. Make sure you guys are writing these examples down, otherwise you won't be able to look at the instructions sometimes. So with this is it called a piecewise function again. Piecewise. So we have negative 3 if x is less than negative 2. So from negative 2 and back, this function is negative 3. And then once I get above negative 2 in my domain, x is greater than or equal to negative 2, I have the function x squared. So that is your parabola to negative 2, which will be negative 2, 4. So I will have that function there. And there is actually the graph of our piecewise function. So it looks like it is increasing from 0 to infinity. So increasing from 0 to infinity. This is decreasing from negative 2 to 0. Right, because that's the part where it's decreasing. And then it is staying a constant negative 3. So constant from negative infinity all the way up to negative 2. All right, here's our next example. Take a second, pause the video, write it down. All right, first thing we're going to do is plug it in our calculator. So there's our function in the y equals. And then we can look at the graph. Well, that doesn't help us very much. But don't forget, you can change your window on this thing. Change your viewing window just like you change your window when you're looking at maps or something like that by going to Window. And I need more space in the y direction. I need to include more graph there. So I'm going to go to the y minimum and make it, I don't know, negative 100. Go to 100, and then YSCL means y scale. So I'm going to go by tens just so it looks pretty. So now looking at our graph, cool. So since it is asking for the extrema of the function, that's talking about relative minimum, relative maximum, things like that. So since this goes to negative infinity in this direction, and it goes to infinity in this direction, I will not have any absolute maximum or absolute minimum. But what I will have is a relative maximum right there and a relative minimum right there. So I can go to second calc, I can find my maximum, go to the left of it, and hit enter, and again my arrow comes up. Then go to the right of it, hit enter, and guess. So my maximum is negative 494 and 4203. So I can say the relative max is the negative 4.94, 42.03. Okay, and then I can look for my relative minimum, which is over there. So I'll hit second calc, minimum, left bound would be like negative 3, right bound would be 5. And there we go. So 0.270, or just 0.27, and negative 28.55. And this would be a relative minimum. So relative min. So 0.27, negative 28.55. And there it is. And pretty much that is all you are going to be doing when it is saying classify the extrema. You can have the absolute minimum, absolute maximum. Don't forget that if it has a graph that looks something like that, this would be your absolute max, right? And this would be your relative max, and this would be a relative min. Okay, so your absolutes are just the most extreme. And notice there's only a relative minimum here because it continues to go to infinity in both of those directions, so there is no absolute minimum. Okay, next thing I'm going to talk about is the average rate of change. Pretty much all that is talking about is from one point to another point, what is the average rate of change? So how much does it change on average? Pretty much all it's looking for is just the slope from point to point, depending on where we are on our graph. Notice that this average rate of change from these 2 points in red is a little bit higher. So it really just depends on which points you're talking about on your graph. Since it is not a linear function, it will not have the same average rate of change all the way throughout the function. But here's your formal definition of the average rate of change. F of x2 minus f of x1 all over x2 minus x1. Pretty much that's just saying y2 minus y1 over x2 minus x1. So just your slope formula that you know. If you do not have f of x2 or f of x1, well, hey, you can substitute those in the equation, whatever equation you have, such that you can find those values and plug it into this little formula here and find your average rate of change, which again is just slope. So don't freak out when we say average rate of change. I'm freaking out, man! Okie dokie, artichoke. So with this one, determining the average rate of change over the given interval, so we are going from -1 to 3. So all that means is you have x1 is -1, x2 is positive 3. So I know in my equation so far I have 3 minus -1. Now I need to find the y values associated with those. Well, if I plug in 3, f of 3, I have -4 times 9 plus 9 minus 4, which is -36 plus 5, so that would be -31. So -31, and then to find f of -1, I have -4 times 1 minus 3 minus 4. So I have -4 minus 3 is -7 minus 7 is -14, so -31 minus 14. Well, I'm pretty sure negative 31 minus 14 is negative 45 over 4. Yep, because plus a negative, or minus a negative will make that a positive. So negative 45 over 4, and we will leave it just like that. Cool. All right, looking at the last one of our notes. Same thing, we're determining the average rate of change over the given interval. We have our x1, you have x2. So I can say we at least know 12 minus 5, plug in 12, so t of 12 should be 12 minus 3 over 12, which is 9 over 12, which is 3 over 4. So I have 3/4 minus f of 5 would be 5 minus 3 over 5, which is 2/5. So 3/4 minus 2/5. Alrighty, common denominators. So multiply this by 5 over 5 and multiply this one by 4 over 4 to get those both have a denominator of 20. So we have 15 over 20 minus 8 over 20 all over 7. Well, 15 minus 8 is 7 over 20. So we have color 7 over 20 divided by 7. Okay, and then we need to multiply by the reciprocal on top and bottom, so 1/7 and 1 over 7. 7 divided by 7 makes 1, and 7 divided by 7 makes 1, so this is just equal to 1/20. There it is. Hopefully this video was helpful for you guys. Again, as always, please ask questions to either your teacher or me. Everybody's willing to help you guys out. Pre-cal is confusing sometimes, so that's why we're here. We love you. Come ask. Well, bye!